Hi everyone, I am starting on page 24. We are going to begin graphing some of these trig functions that we've been learning about. The first ones we're going to talk about are the sine and cosine functions. So if we were to make a table of values, which is what we do when we start to graph anything, we're going to be keeping, let's see, we'll do it for the sine of x first. We're going to be keeping the unit circle in mind here. So remember here we've got the x and the y-axis with these and what these coordinate points are. And everything that we graph for the sine and cosine and all six trig functions will come from the unit circle. We're going to be thinking in terms of radians for our inputs, so we're going to talk about 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to have 5 points here. This is a 5-point method for graphing the sine and cosine curve. So when I think about the sine at 0 degrees, it is 0. The y value there is 0. The sine at pi over 2, because, excuse me, this was the point 0, comma 1, or sorry, I always do that. This is the point 1, comma 0. This is the point 0, comma 1. This is the point negative 1, 0. And this is the point 0, comma, negative 1. Okay, so now we're thinking about all the y values. The y value at pi over 2 is 1. The sine, or the y value at pi, is 0. The sine, or the y value at 3 pi over 2 is negative 1. And the sine, the y value at 2 pi, back one full rotation here, is 0. So when I go to graph the sine curve, I'm going to be starting here at the origin 0, 0. And my intervals along the x-axis are going to be pi over 2, pi, 3 pi over 2, and 2 pi. And I'm just going to plot those points. 0, 0, pi over 2, up 1, pi, 0, 3 pi over 2, down 1, and 2 pi, 0. So my 5 points here go from 0, 0 to 0, 1, to 0, 0, 0, negative 1, and back to 0. 0. Well, in essence, 2 pi, 0. So we've got a midpoint, a high point, a midpoint, a low point, and a midpoint. This line right here would be considered the axis of the graph, like the center line sort of through the graph. All right, now if we talk about the cosine of x, we make our table of values. Now, of course, I'm interested in the x values. So what is the cosine at what is the cosine at 0? The cosine at 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is negative 1. The cosine down here at 3 pi over 2 is 0. And the cosine back around at 2 pi is 1. So I'm at my outputs, because the function is cosine and cosine refers to the x values, the outputs for this function are the point 0, 1, and again this is 1, this is negative 1, then pi over 2, 0, then at pi here I'm at negative 1, at 3 pi over 2 I'm back at 0, and at 2 pi up here at 1. So I finish and connect those dots with a curve that looks like that. So what these little notes mean is just that points 1, 3, and 5 for the sine curve are on the axis. Point 2 is the high point, and point 4 is the low point. And again, on the cosine curve, point 1 here is the high point. Points 2 and 4 are the midpoints, on the axis, and then point 3 is the low point. Okay, on to page 25 now. Remember that we're going to talk a little bit about translations now. So as I scroll down here, these pages talk a lot about translations, but what I want you to focus on is on page 26 right now. I'm talking about these two standard equations here for sine and cosine. Remember that with any transformation, when we talk about A, we talk about some sort of vertical stretch. In this case, it's called the amplitude, or the height of the curve. It's the height from the axis, and it's going to represent a vertical stretch or or shrink, just like it does with any other function. Okay, now we remember h and k. Well, when we talk about h, I'm skipping over b for now, but I'll get to it. When we talk about h refers to a horizontal shift. So h is a horizontal shift to the left or right, just like in any other function. And k, of course, is a vertical shift, up or down. All right, now, so if you scroll back to page 25, and then what you'll see is an explanation of, more detailed explanation of each of these things with some examples. Okay, but back down here on page 26, I want to talk for a second about this b value right here. This guy is important because it helps you understand two things: the period and the frequency. So I'm on page 27 now. And what I'd like you to notice right here is the formula to find the period. The period of the graph is how long it takes the curve to complete one full revolution. So how long it takes to complete one full revolution. That means how many times am I going to see a full sine curve? Normally the period is 2 pi because it's from 0 to 2 pi. Or how long is it going to take to see a full cosine curve? And again, the period normally is 2 pi out here. Okay, now frequency is related to the period, and the frequency is how many times you see the curve, the full curve, how many times you see the curve between 0 and 2 pi. Okay, there's a formula here. I'm going to take the b value of my function, and I'm going to take 2 pi over b. That is going to give me the period. Now when I take b and divide it by 2 pi, and it's the absolute value of b in both cases, because period can't be negative, and neither can frequency. So if I take the absolute value of b over 2 pi, I get the frequency. So it's important that what I do here, and you'll notice how this is written, I have to make sure that I factor out b when I go to graph and answer questions about any kind of transformations in these two functions. Excuse me. More notes here. And in the next video, we're going to get into some examples.